Okay, the subject of minerals is very important to nutrition because our bodies are made of some 97 different minerals. The mineral that is the most prominent in our body is what?
Calcium.
Calcium, right. Calcium is what makes most of our bones, and the bones are the heaviest part of our being. There are 7 major minerals, and there are 8 minor trace minerals that we're going to talk about tonight. There are actually 90 trace minerals that one could talk about, but as far as we know, most of those don't have any major impact on health. The major minerals are sodium. Sodium comes from salt. Sodium chloride is salt. The second is potassium. The third is phosphorus. The fourth is magnesium. The fifth is sulfur. The sixth is calcium. And the seventh is chloride. Those are the major minerals of which we're made. And those minerals are taken in each day in our food in milligram amounts, and in some cases, many milligrams. The 2 major ones, sodium and potassium, are the 2 most prominent minerals in our body. Sodium makes up the salt in the extracellular fluid, that is the fluid outside of our cells, whereas potassium makes up the major mineral inside the cells. So we have high potassium in the cells and high sodium outside of the cells. Sodium is the major extracellular fluid ion that tends to control blood pressure and that tends to control our circulatory system, because that part of our body is outside of the living cells where life really takes place. But because of the way we're made, the circulatory system is outside of the cells. Our heart pumps blood outside of the cells and transports oxygen to the cells through the circulatory system. And sodium is very important in that regard. And if your body doesn't have enough sodium, then your blood pressure drops, and you actually can go into a coma because of a very low sodium. On the other hand, if you take too much sodium, what happens? High blood pressure. And so it has the opposite effect. Makes the volume of the circulatory system increased, and therefore the blood pressure rises. And so it's obviously important that we have just the right amount of sodium and not too little or too much. Now, fortunately, the world has lots of salt. Salt is about 1% of the sea, and so there's an unlimited amount of sodium in the world. And if one were having a shortage of salt, all we would have to do is take seawater and take the salt out of it, and we'd have more than enough, because the 3/4 of the surface of this earth is covered with water, and most of that is salt water. So the major ion in our body, and the word ion simply means a chemical substance that is not attached to another chemical substance. And in the case of sodium, it is attached to chloride. Sodium chloride, that's what salt is, okay? And so sodium is a positive ion, and chloride is a negative ion. And so positive and negative stick together and attract each other, and that's what salt is. Now, in the inside of the cell, the opposite is true, where it is potassium that is the major ion, and it again is attached to chloride. And so the level of sodium on the outside is kept that way by a pump mechanism in the cell that pumps sodium out of the cell and pumps potassium into the cell. And that pump mechanism is critical for life. Without it, we would never have living cells. And so that pump that pumps sodium out into the circulation and potassium into the cells is critical for the way that these two elements affect us. Now, potassium is also very important in cardiac function. And if we have too much potassium, it causes the heart to stop. And if you have a patient who has a cardiac arrhythmia, let's say they're in atrial fibrillation, you've heard of that. Atrial fib is a condition where the heart is beating much faster than normal and the pacemaker is not working properly. And if that person then is given a dose of potassium, it may help if the potassium is low. On the other hand, if the potassium level in the blood is too high and the normal level is about 4, quite a low side, whereas in the cell it's 150, okay? So remember that there's a pump that's pumping the potassium out into the blood, and there's another pump that's pumping the potassium into the cell and sodium out of the cell. Okay. Where do you get potassium? Bananas, right. A great source of potassium. And it's true that most fruits have quite a bit of potassium. And so fruits are a key element in the nutrition relative to potassium and sodium intake. Now, it is true that we use sodium for what purpose? We use sodium because it makes our food taste good. Yeah. We add sodium to the food to make the taste better. And so it's customary for many people to have a salt shaker on the table, and when they sit down to eat a meal, what do? They add salt in it. And so that's okay if your sodium level is on the low side, but if your sodium level is high, or if you have high blood pressure, what's going to happen if you add salt?
It's going to raise it.
It's going to be worse.
There was no salt added to dinner tonight at all.
Another place that is
That's not true.
No, well, the soy juice was what I added to make it so salty.
And soy juice is full of sodium.
Dialysis patients are another one that has lots of trouble with their salt and potassium levels.
Okay. Now, I'm going to leave the latter part of our talk tonight for questions. And so if a question comes to your mind or something I've said doesn't make sense, make a note, and we'll deal with those questions a little later. So those are the two major ions in our body, sodium and potassium. Sodium on the outside of the cell, potassium on the inside of the cell. But if you take a big dose of potassium, and I had the experience when I was a resident doctor in internal medicine residency, I had a new intern that just started work with me the first day of his internship. And we had a patient on rounds that had a low potassium. And so he thought, we can fix that. I'll just give that patient a shot of potassium. And he did. And if you give potassium IV very rapidly, you'll kill the patient. And he did. He killed a patient. He didn't know what he was doing, and he thought he was doing the right thing. But the point I'm making is that potassium given intravenously, unless you give it very slowly, can cause a lethal arrhythmia in the heart and cause the heart to stop. And so too much potassium in the blood is a dangerous level. And so the body is designed to keep the potassium in the blood at around 4, whereas the inside level of potassium in the cells is 150. Now, let's move on now to some of the other major minerals.
The next one on the list is phosphorus. Phosphorus is a major part of our bones. Phosphorus is combined with calcium in a compound called calcium phosphate, and that makes up the major structure of our bones. It also has a major role in energy metabolism because there is a compound in our body called ATP, and that ATP stands for adenosine triphosphate. Okay? And that is a high energy molecule. Most of the energy in our body is turned into ATP before it is used for energy. And so ATP, which is a phosphorus-containing substance, adenosine triphosphate, means it has 3 phosphorus groups in that one molecule. Question? Yes, it does. Mm-hmm. So phosphorus is extremely important in both bones and in teeth and in the metabolism of the body, and there's a tremendous amount of very complex chemistry tied up with phosphate. And I'm a chemistry major, and so my wife said, forget that. Don't say anything about that to the people because they won't know what you're talking about. And so I'm going to move over that, even though it's very important. Phosphorus is extremely important, and a healthy amount of phosphorus in our diet is extremely important. Fortunately, it's available in all the foods we eat. There's no likelihood of anybody ever being deficient in phosphate. The next ion is magnesium.
Magnesium is also a positive ion, that is, it has a positive charge, as does phosphorus. Phosphorus can be either positive or negative, and so it can be attached to another cation, which is a positive ion, or an anion, which is a negative ion. Magnesium works in a wide variety of enzyme functions in our body. Enzymes are substances which promote chemical reactions. That is, if you have a chemical reaction that is necessary, let's say to make ATP, to make that energy stuff, the enzymes that are necessary to cause that chemical reaction to occur are all short protein molecules. And those enzymes cause many, many chemical reactions to take place. I mentioned yesterday, you may recall, that in your liver cells, there are 2 million chemical reactions per second. Okay? So you're sitting on a chemical powerhouse in your liver. That is where most of the body's chemistry takes place. The liver is where poisons are detoxified and where some poisons can kill you. It's also where most of the proteins in the body are manufactured. The major protein in the blood is called albumin, and that is made only in the liver. And many other proteins that are necessary for life are synthesized in the liver cells. And the material from which those proteins are made are amino acids that come in from your protein in your diet. Okay? How many did we say there were? 20. There are 20 amino acids, and of those 20, depending on how they're mixed together, you can make thousands of different proteins. And our bodies are capable of doing that. And phosphorus is, and magnesium is a major part of many of those enzymes. Sulfur is the next one, and sulfur is in our body because it is present in 2 of the 20 amino acids. The 2 amino acids that have sulfur in them are cysteine and methionine. And those 2 amino acids having sulfur in them, when they break down, that sulfur has to be gotten rid of, because sulfur in our body in the presence of acid becomes sulfuric acid. You all know what that is? That's the most powerful acid there is. It's extremely powerful, and it would burn us up if it wasn't gotten rid of very quickly. And so there is a special mechanism by which those sulfur residues are gotten rid of in the body, and that has to do with one of the trace elements that we're going to talk about in a few minutes. So, sulfur is present naturally because it is made, the protein, almost every protein that is made has some sulfur in it, because these 2 essential amino acids, methionine and cysteine, are very important amino acids in the body. Okay, let's move on to calcium. Calcium, I said, is the most abundant mineral in our body, not in terms of what's in the blood, but what's in the bones. And calcium and calcium phosphate in particular make up the major part of bones. Teeth also have calcium. And then calcium is also extremely important in the nervous system. The neural mechanism by which nerves conduct electricity from one part of our brain to another, or from the brain to the muscles where a signal goes that says contract, is carried by calcium ions. So calcium is a very important ion both for structural protein in the bone and also for neurotransmission.
And then the last of the major elements, ions, is the chloride. And we mentioned that chloride is the bigger half of salt. Chloride has a molecular weight of 35, whereas salt has a molecular weight of 23. And so sodium chloride is made of these two ions chemically bound together. And chloride is important in the body in that it is the primary substance that is made into the acid that digests our food. And what is that acid? No, hydrochloric acid. Hydrochloric acid made in the stomach by the parietal cells in the stomach. And that acid is a very potent acid, very much like sulfuric acid, except it's made of just hydrogen and chloride, HCl. And our body has a way of getting rid of that. In fact, when hydrochloric acid is secreted in our stomach, and the major trigger that causes that to be secreted is protein in the diet, and that then is neutralized immediately as the food leaves the stomach in the first part of the small intestine, in the duodenum. The duodenum is the shortest segment of the small bowel, only about a foot long, and that part of the small bowel has as its major function the neutralization of hydrochloric acid. So that by the time the food gets down a foot from the stomach, it's back to normal, back to a pH of 7, which is neutral, okay? But that part of the anatomy, the duodenum, is extremely important because there are a number of things that are absorbed primarily in an acid environment. And that is the duodenum, because that's where the acid is dumped from the stomach where it is made, and the acid helps a number of things to be absorbed appropriately. One of them is calcium. Calcium absorption is very acid dependent. Without acid, you don't absorb calcium hardly at all. And also, there are several other things that are absorbed better in an acid medium. Iron, for instance. Okay, those are the 7 major elements, or minerals: sodium, potassium, phosphorus, magnesium, sulfur, calcium, and chloride. All right? Now let's move on to the trace elements.
When we say trace elements, we mean elements that are present in the body at levels of less than 20 milligrams percent. And that's kind of an artificial definition because most of the trace elements are in microgram amounts, very small amounts. And the 8 trace minerals are iron, chromium, copper, zinc, iodine, manganese, selenium, and molybdenum. Now let's talk about each of those just briefly. And this is where we could just really get carried away if we went too far. So I'm going to just be very superficial in this part of the lecture because I don't want to overwhelm you with chemistry. Iron is the first one, and iron is perhaps the most important of the trace minerals because iron is necessary for red blood cells. We cannot make red blood cells without iron. And so iron is part of the molecular structure of hemoglobin. Iron sits right in the middle of the hemoglobin molecule and does some important things there. It is also very important in another protein that is present in muscle. Muscle cannot function, cannot contract without this protein containing iron. And so those two parts of our body, the blood and the muscles, are very iron dependent. And when you don't have enough iron, what do they call you? Anemic, okay? And so who in our society is most likely to become anemic? Women. And why? Because they lose blood every month. And so women require twice as much iron in their diet as men do, about 20 milligrams a day, whereas a man can get by very easily on 10. Where do you get iron?
Beets.
You can get it in all kinds of green vegetables. Spinach, of course, is the famous one. Popeye, the sailor man.
I think of Geritol.
Geritol. Well, Geritol is probably a good product if you have stock in that company. I wouldn't recommend it otherwise. Okay, so let's leave iron and go on to chromium.
Chromium is an element that is present in the body in very minute amounts and required in the diet in microgram amounts, very, very small amounts. But it is very important in the mechanism of insulin. Insulin does its work of transporting glucose across the cell membrane into the cell from the blood by a mechanism that is chromium dependent. So chromium is very important in insulin metabolism. Copper is the next trace element, and copper is important in energy metabolism. It's also important in iron metabolism. It's necessary for the formation of hemoglobin, and so you can become anemic from copper deficiency. It also is very important in connective tissue. Connective tissue is our tendons and the things that attach our muscles to our bones.
And it's also very important in the brain. So copper metabolism is complex, very complicated, and way too much chemistry for us to talk about here. But remember that we only need a couple milligrams a day. So it's not needed in very large amount.
Where do you get it?
And copper comes from lots of fruits and vegetables. You don't have to worry about copper not being adequate because it's present in the ground everywhere in the world. Yes?
I've seen some people wearing copper bracelets.
Yes.
That actually get inside the skin and glitter.
Not a very good way to get copper. The absorption of copper through the skin is minimal. And the scientific data for the benefit of copper bracelets is non-existent.
Wow. So another thing.
Except for the people who sell those bracelets. So copper is important for a number of metabolic functions, but it's really interesting that copper and zinc have a reciprocal relationship. That means that when you take too much of one, it causes the other one to be deficient. So if you don't have enough copper and you have a lot of zinc in your diet, then you become copper deficient. And on the other hand, if you have too much copper and not enough zinc, you become zinc deficient because their absorption mechanism in the small bowel is dependent on the same mechanism. And so they're reciprocally related, and so you need just the right amount of each in order to get plenty in your diet. And again, it's only a milligram or two that is needed. Zinc is very important in the immune system, that part of our bodies that recognize foreign proteins, foreign viruses, foreign things that would otherwise damage our system. And the immune system is a surveillance system that our body has that keeps us from being contaminated with other protein substances. And the immune system has the ability to copy any kind of an insult that comes in and make an antibody to that substance. Antibodies are there are millions of different antibodies. And the immune system is capable of making these antibodies in cells in our bone marrow that are called myelocytes. There are several other cells that make antibodies also, but that's one of the major ones. And the immune system is able to prevent us from being invaded by viruses and things like that by making these antibodies, which are antibody to that substance. Now, we talked the other day a lot about autoimmune diseases. You remember that? And what we said was that autoimmune diseases are a situation where the immune system attacks itself. Autoimmune thyroiditis, the thyroid is destroyed. Autoimmune hepatitis, the liver is destroyed. Autoimmune arthritis, rheumatoid arthritis. And so there are many different autoimmune diseases, and those diseases are a situation where a foreign protein that is so much nearer to the body's protein that the immune system can't tell the difference. And so it makes antibodies to this protein substance that it recognizes as self and so part of self is destroyed. You follow us? Okay. So autoimmune diseases are a very, very big thing in medicine today, and it's interesting that in the last 25 years, the number of autoimmune diseases that have been recognized and characterized has doubled or quadrupled, and it's now a major, major menace in our society. Okay, the next one is iodine. Iodine is present in the body primarily in connection with one of the hormones in the body. And what would that hormone be? Nobody knows. Thyroid hormone. Thyroid is tetraiodothyronine. That's the name of the chemical. And it has 4 iodine molecules attached to a series of amino acids. And so T4, we call it, that is thyroid hormone. And thyroid hormone is the primary hormone in our body that keeps us going at a normal pace. If you don't have enough thyroid hormone, you become hypothyroid and your body slows down. Everything slows down. You become constipated, you become no energy, and you can't do much. Whereas if you have too much thyroid, then you become overactive, and hyperthyroid means that you're making too much T4. And so iodine is very important in connection with just that one hormone. In fact, that's the only place that we know of where it works in our bodies. The next is manganese. Manganese is important in a number of enzymes in the body that are antioxidant. Antioxidants are substances that fight free radical formation. Free radicals are chemicals that destroy cells. And so an antioxidant is a protective substance that keeps these free radicals that are circulating all the time in our food supply from damaging us. And so if you have enough antioxidants in your body, you don't get as much injury as you would otherwise. Yes?
Is glutathione the body makes, that's an antioxidant, correct?
Yes, that's one of the antioxidants.
Catalase and SOD or superoxide dismutase,
Mm-hmm.
those are antioxidants, correct?
Right.
Okay, good.
The next trace element is selenium, and selenium is important in that it is active in protein metabolism in a substance called selenocysteine. You remember that sulfur-containing amino acid we talked about? And selenocysteine is an enzyme-containing substance which promotes the metabolism of that kind of an amino acid. And so selenium is necessary to digest protein. And the last one is molybdenum. Molybdenum is a substance that is attached to another of these enzymes, the major enzyme that is necessary in the body to get rid of sulfur. Sulfur, remember we said, can become sulfuric acid and really upset the body's pH. And so we have to get rid of the sulfur, and the way the body does that is to convert the sulfur that is in the amino acids that we talked about into a sulfate. A sulfate is a type of sulfur that's attached to oxygen, and it's water soluble, and it can be excreted in the urine very efficiently. And so this enzyme, which is called sulfite oxidase, contains molybdenum, and that will help to remove the breakdown product of protein that contains sulfur. Okay? Now that's all I'm going to say tonight, but I'm going to try to answer any questions that you may have as we've gone along, and we'll try to be as clear as we can be We are fearfully and wonderfully made. And we have come to understand the physiology of the body maybe 1%. The vast majority of the chemical reactions that occur in man are still unknown. And substances that are very important in health have still not been found. And so we're in a quest for truth continually, and the research that is going on in the National Institutes of Health and other research organizations around the world we're just beginning to scratch the surface of what there is to be known. And I'm really looking forward to the day when I can sit down with the Creator, Jesus Christ, and talk to him about how he did this. How he did this. I mean, it's going to be an incredible conversation. And I'm going to ask him some questions about what is it in the tree of life that he has created that will repair our bodies and make us all eternally young. We'll never get old. There's something in that tree that is possible to repair all of the damage that sin has caused over the how many thousand years that the world has existed. And you know, it's interesting, as a physician, I have had the privilege or the dishonor of having seen many people die, seeing people with disease. As a gastroenterologist in particular, many people who had stomach cancer and colon cancer and liver cancer and pancreatic cancer, the very lethal kinds of cancer. And so I'm looking forward to the day, and I'm a diabetic. I've been a type 1 diabetic for 45 years. And I'm looking forward to the day that I don't have to take insulin anymore. And what a day that's going to be. You know, I have to check my blood sugar 5 times a day, and I have to continuously be on guard for my blood sugar going low. Today I climbed the mountain at home, and I got up to the top, and I was just not moving very well. And I took out my continuous glucose monitor out of my pocket, and my blood sugar was 50. Normal blood sugar is 70 to 110. And so I was running out of glucose. Fortunately, I had some candy in my pocket, which I always carry, and I was able to restore it. But the problem is we all suffer from diseases of one sort or another that are part of us. And we are all damaged goods, and some of us more damaged than others. But I think a diabetic has to be one of the most damaged people in the world, because insulin is absolutely necessary for life. And so I'm looking forward to the day when I meet my Creator and he's able to fix that pancreas and make it make insulin again, and all the other defects that I have.